Welcome back to the decision tree module. I'll refer to this decision tree which we've seen earlier to explain the different terminologies that we'll often encounter when we're dealing with decision trees. The first one is what we call a root node. A root node represents the entire population or the data that we have. Root nodes further get divided into two or more sets, which we'll just see in a moment. The second terminology is splitting. Splitting is a process of dividing a node into two or more subnodes. The highlighted lines here represent the splitting as a node is being split here into subnodes. Now, when a subnode is further divided into even more subnodes, then the initial subnode, we'll call that a decision node. So here these two highlighted nodes are the decision nodes. Now the nodes which do not split further are called the leaf or the terminal nodes. In our example, these four nodes are the terminal nodes since they're not splitting any further. A subsection of the entire tree is known as a branch or a subtree. So in this example, these are the two branches or subtrees of our initial complete decision tree. We then have parent and child nodes. A node which is divided into subnodes is called a parent node, whereas the subnodes will be called the child of the parent node. Don't worry, let me explain this with a very simple example. So let's say these are the names associated with each node A, B, C, D, E, F, G here. So when we look at this particular section highlighted in the red border, A is the parent node and B and C here are the child nodes of A. Similarly, in this, B is the parent node and D and E will be the child nodes. And of course, you must have guessed this by now. C will be the parent node and F and G will be the child nodes. Finally, there's one more terminology called the depth of a tree. It is the length of the longest path from the root node till the leaf node. When we look at this particular example, the longest path here is 2 and hence the depth of this tree will be 2. Now consider this tree. The longest path is still 2. So that's why we'll keep the depth to 2 as well. What do you think about this? The longest path clearly is only 1 and that's why the depth is 1. Finally, the longest path in this tree is 3 and that's why you can see the depth is equal to 3 there. Now I have a question for you. Can you tell how many leaf or terminal nodes there are in this tree? Again, I encourage you to pause this video and it'll take you a second to come up with the answer. Just remember, leaf nodes are the nodes which do not split further. And as there are 1, 2, 3, 4 and 5 leaf nodes here which are not splitting any further, that's why we'll call them 5 leaf or terminal nodes in this tree. These are some of the common terminologies related to decision trees. In the next video, we'll look at some techniques that you can use to select the best split points in decision trees. Thank you.